Hi, I'm Dr. Evan Matthews. I'm an associate professor at Montclair State University, and I'm going to be presenting low-cost exercise science laboratory instructional approaches for a pandemic situation. And this is part of a session at the Mid-Atlantic Regional chapter of the American College of Sports Medicine, all about online laboratories for exercise physiology. So to look at what's out there in the peer-reviewed literature, so just to say right up front here, there's really minimal out there, especially if you're focused on the exercise physiology literature. I did find a recent review article that was in general physiology, so not specific to exercise physiology. You can scan this QR code here in order to access that paper. But in this Zhang et al. Paper from 2021, they found 11 studies that met their strict inclusion criterion. And of those 11 studies, only 2 of them were exercise physiology studies. So again, not a whole lot on exercise physiology. They had 4 studies that compared fully virtual to fully in-person laboratories. And so this is similar to what most of us experienced at the beginning of the COVID-19 pandemic, when we were kind of forced in lockdown and couldn't really do anything in person. 6 of the 11 used a blended version, so some in person, some virtual, versus fully in person. So this is probably more similar to what most people are doing now as we sort of transition to a life or new normal that's a little bit more like the old normal. So that's the sort of breakdown of the studies. They focused on 3 different types of learning. Okay, they did concept learning, which is did the lab enforce physiological concepts from the lecture material. They looked at motivational learning, which was did the students have a significant amount of motivation to really engage with the lab material and learn from it, and basically were they motivated by the lab. And then they did technical learning, which was whether or not they learned to use scientific equipment, conduct data analysis, interpretation, or presentation of the data. So in my opinion, I wish they would have done more of the scientific equipment or some skill-based learning, but they did kind of have this pretty broad category for the technical learning. So I'll talk about the findings from this review article as I go throughout my talk here, but I just wanted to sort of overview this, and also I will be using some of the same terminology throughout this talk. All right, so in my labs, since the COVID-19 pandemic has begun, I have essentially 3 different types of online or virtual labs I've done. And each of these I've done in a fully virtual and a sort of hybrid format more recently. I'll talk a little bit about each of those as we go. All right, so the physiological theory labs, which I think focus mostly on the concept learning, the active asynchronous exercise labs, which I believe is more in the motivational learning category, and the skill-based labs, which I think pretty clearly falls under the technique learning category from that review article from Zhang et al. And so we're going to go through each of these types of labs and give some examples and kind of overview what I did, as well as some student perceptions and things. All right, so starting with the physiological theory discussion labs, each student was given a handout. It was a Microsoft Word document with an introduction section, a method section that included both text and videos. And the videos, I think, are pretty important for the virtual format, so that the students get more of a real-life experience. So if you want to see some examples of those videos, you can scan this QR code there, and it'll take you to that series, a playlist of a lot of the videos I use in my labs. And then they also had an example data collection sheet within the handouts, so they could see what would normally be recorded if they were conducting the lab themselves. And then there was 4 discussion questions at the end. They were also given a data sheet. This is a Microsoft Excel document, and in the data sheet was the full data set from a previous course prior to COVID-19, where I was doing all this stuff in person. But you could pretty easily substitute for this a figure and statistics from a published paper. But I also included figures that I made myself and statistical tests with the results that I did for them. So they really didn't do the analysis so much, but they will do the interpretation of that analysis. All right, so to get to the student responsibilities, to independently review the information prior to coming into the lab. They were then to form groups of 4. When I was doing this fully online, this was done through Zoom breakout rooms, so it was just randomized, and so they didn't actually form their groups themselves. Now I'm actually using, for all my classes, a more flexible model where students can choose each class whether they come in person and get a somewhat in-person, somewhat blended environment, or a fully virtual environment where they attend through Zoom. So for those who are choosing to attend through Zoom, they're still getting randomized breakout rooms. For those who attend in person, they are getting to choose their groups of 4 from the people that are there. And then within their groups of 4, they are to then discuss those 4 discussion questions I mentioned that are at the bottom of the handout. Then for the assessment, each group has the ability to meet with me twice during the lab session. The first time they meet with me is an opportunity for them to ask me questions, so to get some clarification of things, to sometimes give me what they think the answer is to something, and I kind of guide them if they're a little off track, or to ask any other kind of questions about the lab and the methodology to help clarify what exactly they're trying to understand about the lab. The second time that I come to their lab group, each member of that lab is going to be asked one of those 4 discussion questions at random. So they don't know which one they're going to get, and they have to answer it orally, and they're graded on their understanding of that question through their oral answers. So it is a really quick turnaround from the beginning to the end of the lab where the grading takes place. All right, so let's talk a little bit about the what's out there from the literature, as well as my perceptions and the student perceptions. And this is the general format I'll be doing for each of these lab types. All right, so again, this type of lab, the physiological theory discussion labs, I think falls under the concept learning from that Zhang et al. Paper. And they found that 90% of the studies that tried to evaluate concept learning did find successful learning outcomes under this category for virtual or blended labs. Then my instructor perceptions of this. So the pros, there's a lot more time and attention focused on the theories. So for an exercise physiology class, I actually think this is a really good thing, because in the past, when everybody was collecting the data and they were really focused on the methods, they just didn't really focus as much on the theories behind the lab. And oftentimes, I think that got overlooked. So there's also the opportunity for both formative and summative assessments in that very short time span, because the first time I meet with them, again, they get to ask me questions, and that's the formative assessment. And then at the end, where the grading takes place with their oral questionings, that's the summative assessment. It's happening really rapidly, so it's a very time-efficient way of doing both types of assessments. And then also the students come to class much better prepared than what I used to experience when they would come in, collect the data, and then go home and do the assignments on their own as a written assignment. Because then they felt like they could come in, figure it out as they go, and then figure out exactly what the assignment was after the fact. Now they come in ready to go because they're going to be graded during the lab time. Some cons from my perspective. There is greater student anxiety because of the oral grading that takes place. And there is a little bit more subjectivity to the grading because I'm grading on the fly, and it's kind of hard to go back and forth between students and alter grades if I change the way I want to grade it, and sort of things that you can normally do when grading written assignments. So again, a little bit more subjectivity to the grading doing this type of lab. Now the student perceptions of this. So I asked my students to tell me which type of lab they prefer of the 3 types I'll be talking about today. In the exercise physiology class, 23%, so that's 7 out of 30 students, prefer this physiological theory discussion-based lab. So about 1 in 4 students prefer this type of lab. It's not a huge number of students, but still, a significant enough number where I think there's some real cause for, or real reasoning for using these labs in the future. Then I also asked them if they're going to do this type of lab, so if they're going to do the physiological theory discussion labs, should they be attending in person or virtual? So should I mandate in person or virtual attendance? 50% of them said that they prefer it to be an in-person lab. 30% said virtual, and another 20% said had no preference. So a little bit more of them said that they prefer it to be in person. And as I mentioned earlier, right now with my current semester students, I give them the option to attend in person or virtual each class, and they get to decide that on their own. They just attend however they want to attend, and I've been tracking how they attend. So if you look at the actual attendance data from my current exercise physiology classes, when we do these physiological theory discussion labs, the attendance rate is about 54%. So it lines up pretty well with the preference data. When we look at the classes where there is either no lab or the lab is some form of asynchronous lab, so not this category of lab, the attendance only dips to 49%. So really no difference between the two types of class sessions, especially when you start looking at the error bars here. So whether or not they have this type of lab doesn't really seem to impact whether they attend, though. So it's kind of hard to say if the lab is driving much, if any, of this, any of the attendance, that is. So then I asked them, when you attended virtually, why did you choose to attend virtually? 57% said the primary reason was convenience. They simply liked being able to log on from wherever they are and not drive to campus and not deal with traffic and parking and those sorts of things. 13% said they were trying to avoid COVID-19, so not a whole lot of students who were concerned with COVID-19 compared to convenience. And then 10% just preferred the virtual option for attendance and preferred that environment. I asked the same question for when they did attend in person, why did they do so? So 53% said they preferred that environment. So there's clearly a preference for an in-person environment. 10% said for social reasons, and 7% said to avoid technology. So primarily, why do they attend virtually when they do? For convenience. And primarily, why do they attend in person when they do? Because they just like the in-person environment. So some useful information there. There's a sort of balance, give and take between preference and convenience then. All right, so on to the next type of lab. We're going to do the active asynchronous exercise labs. Again, the students were given handouts with an introduction section, a method section that had both text and video. And so I put here an example video with a QR code if you want to see a specific video used for this type of labs. This is for a lab that I actually have coming up in a week or two. And so this is what's given to the students. The student responsibilities is to conduct the exercise test on themselves or in a subject of their choosing in their personal life, and they are using commonly available equipment in order to do the assessment. So things like smartphones in order to do the assessments. So how do I assess them? So it depends on the class. Okay, so I have an exercise physiology class that does this kind of lab, and also an exercise assessment class that does this kind of lab. For the exercise physiology students, they conduct the lab, they collect the data on the exercise test, and then they submit that data through a Google form, and I then collect that together, and in the next class, we discuss it as a class. But the grade associated with the lab is simply them submitting their data. So it's a fairly easy lab in terms of the theories and concepts here. For the exercise assessment students, it's a little bit different. They have to evaluate the fitness level of the individual from the lab data they collect, and then submit a written homework assignment where they interpret those results and what that means in terms of exercise prescription and things like that. All right, so I'm going to go over an example lab for each of these classes, starting with the exercise physiology class. For this class is the lab that I've already conducted this semester. We did stretching versus vertical jump performance. So as most of us know, static stretching is typically associated with a decrease in performance in strength, power, speed-based activities. So we had them do vertical jump testing before and after stretching, and then the vertical jump tests themselves were evaluated through cell phone-based apps. So basically they recorded video of the person jumping, and based on the air time calculated how high they jumped, so what their vertical jump was. So we did run into issues with this though. In the past, when I've conducted this in person and we use Vertex like what you're seeing here, the data worked out pretty much exactly like I would expect. So vertical jump performance went down after stretching. We didn't see any difference between pre and post stretch in this lab this semester. So it's the first semester I've done this specific lab. And what I think the problem is that the videos that we record on a typical cell phone are recorded in 30 frames per second. And this is not quite fast enough to precisely determine how long they're in the air for. We need more a faster recording frequency in order to do that, to minimize the error, to really be able to see what the vertical jump was. So I think that was the reason why we didn't see anything. But even though the lab didn't go according to plan, the students still got to experience the test, the vertical jump test. They still got to interpret the data. They still got to then troubleshoot and try to figure out why the lab did not work. So we kind of, as a class, discussed why it might not have worked. This is the reason I proposed. Other reasons the students proposed were lack of motivation, lack of proper warm up, even though they were supposed to warm up, and things like that. So they were able to sort of think like a scientist and figure out why it didn't work. So a possible solution, so I do intend to do this lab or an iteration of this lab in the future, would be to change the theories I'm trying to show. So instead of looking at static stretching versus vertical jump performance, I think what I'm going to do next time is to use something that I would expect a higher effect size for, which is stretch shortening cycles and how they impact vertical jump performance. So basically have them jump once with a counter movement and once without a counter movement and see the difference. So I would anticipate this working out much better, even with the slow recording frequency, because I think the effect is going to be much larger, and so the error might not be quite as impactful. But I could be wrong. I change these labs every semester as they work or don't work, so this is part of the process, though, and as all of you know. All right, so let's talk about another active asynchronous exercise lab. This is for the exercise assessment and prescription course that I teach. And for this class, it's all about fitness testing, essentially. So I had them doing cardiorespiratory step testing, but we had to do it at home. This actually started. We started using this, or I started using this type of lab way back when we were still under lockdown, and we couldn't have the students leaving their homes. They weren't supposed to be traveling unnecessarily, so we were very limited in what we could do. But again, they had to do some sort of cardiorespiratory step test and interpret the results and how it impacts cardiorespiratory fitness exercise prescription. The obvious problem is students don't have step tests. They don't have aerobic steps in their home. Most people don't own these things. And every available step test, think the YMCA step test, the Queen's College step test, they all use a prescribed step height. So you have to have a step of an exact height in order to do the test, which is why these aerobic steps are so great. But again, nobody has these in their home. So we came up with the potential solution to use other objects, because again, people don't have aerobic steps. Things like staircases, chairs, sturdy boxes, maybe a sturdy coffee table. But again, we run into the problem that they're not the right height. They don't meet the protocol specifications for any of the step tests, or certainly not for everybody, right? So not everybody's going to have a 12-inch step like what the YMCA step test requires. And so it didn't completely solve the problem. So we, myself and some colleagues, actually decided to investigate this and try to come up with a solution. We use research to try to come up with a solution so we can better teach our classes in virtual environments in the future as well. And so what we did is we tried to create what we call the variable height step test. And with this, it is it's based on YMCA step test as a model, and we just sort of modified the approach a little bit. So again, the YMCA step test uses a 12-inch step and a step frequency of 24 steps per minute. So what we did was we plugged this into the ACSM metabolic stepping equation. So that's what we have right here. And we solve for the VO2, the aerobic work rate. And so we got 25.8 milliliters of oxygen per kilogram of body mass per minute as the work rate of the YMCA step test. And then what we did is we recruited lots of people. We had about 40 or so people complete the study. Each person had to choose 2 objects in their home that were very different step heights. As you can see here, ideally, one step would be below 12 inches and one step would be above 12 inches. So we would kind of go across the range of what the YMCA step test is. And so they would measure those step heights, and we rearranged the ACSM formula to solve for step frequency when the VO2 is known and the step height is known. So we plugged in the 25.8 mLs per kg per minute as the VO2. That is from the YMCA step test protocol. And then we plugged in whatever the height of each of their steps were. So we did that twice, once for each step that they used, and we solved for the step frequency. So basically, we tried to keep the VO2, the estimated VO2, the same, although we were changing the step height and step frequency, frequency being a compensatory change to deal with the step height. And so this, we thought, would allow us to use pretty much any step height we wanted in order to conduct a YMCA step test, or for that matter, this approach could be used with other step tests. And so just to quickly show, we were able to get this published in the Measurement in Physical Education and Exercise Science recently. This is a 2021 paper. And so just the primary finding here, the large step versus small step, the heart rate response was almost the same, right? So really high R values and really high intraclass correlation coefficients. So we had really reliable and repeatable heart rate and, not shown here, but RPE responses from these 2 different step heights, despite the fact that they were very different step heights when we, again, match for the estimated VO2. All right, so you can scan this QR code if you want to see this paper. But this shows us that this type of protocol can be used in order to modify pretty much any situation where there's some object you can safely step on and off of in order to do cardiorespiratory fitness tests. And importantly, we did all of this virtually. So this entire study was conducted virtually. And so it shows that this can be done in virtual classes too. And that's what we've done. So, if you pardon my little tangent here to describe how we got to this point, then the variable height step test is something I've used repeatedly over the semesters throughout the COVID-19 pandemic, and I will likely use beyond the pandemic as well. All right, so what does the literature say about these motivational style labs, which again, I'm using my active asynchronous exercise labs as a motivational type lab. 83% success rate across the 6 studies in the Zhang et al. Review article that tried to evaluate motivation from virtual and blended labs. So for the most part, they seem to be working to motivate the students to engage with the material. However, that was across both virtual and blended labs compared to in-person labs. When you only look at the virtual versus in-person labs, so fully virtual versus fully in-person, there were only 2 studies within that review article that did this, and the success rate was now 50% because one showed that it worked and one showed that it didn't work. So it's a little unclear whether you can truly motivate the students through virtual labs. Likely you can with some creativity though. right, so my instructor perceptions on this, look at the pros. High amount of student autonomy because they are conducting the tests completely on their own. Clear connections to real-world applications because they're doing it in a real-world setting with real-world tools. So something that oftentimes we don't do because we have these sophisticated labs where we can do pretty sophisticated things, but our students most often will not have those sophisticated pieces of equipment when they get into the workforce. And also high amount of student interest and motivation from the lab, which is sort of, one of the reasons for doing this type of lab. Again, I'm trying to push the motivational learning with this type of lab. And based on just talking to students, they did seem to enjoy these sorts of active labs, even if they were doing it at home on their own. All right, so the cons, though, is minimal focus on physiological concepts. So similar to my opinions on my old labs, when everything was in person, they'd come in, they do they follow the methods, they'd sort of, stumble their way through the data and that collection, and then they would go after class and try to figure out what it all meant and try to, really read it at that point in order to do whatever the assignment was. So they didn't really focus on the concepts. They just kind of focused on the methods, and then, the concepts were more of an afterthought. So it might not be great for that, which is maybe the other type of labs that I'm describing would be a little bit better if your focus is really on, showing a physiological concept. But that's just my perception. So again, I asked the students of the three types of labs that I'm talking about today, which were the preference. 30% of the exercise physiology students chose this active asynchronous exercise lab. So slightly higher than the discussion-based labs I've already shown, but still not, a vast majority of students. But about 1 in 3 versus the 1 in 4 for the discussion-based labs. Still a significant number of students, though, who like this kind of lab and prefer it. When asking if this kind of lab should be conducted as it was at home in an asynchronous virtual setting, or if they would prefer it to be done in lab with the tools that, again, they have, like smartphones and things like that, it was pretty split. So about 40% preferred in person, 30% virtual, and another 30% didn't have a preference. So a little bit more of the people preferred in person, but not a lot more. This is for the exercise physiology students. I asked the same question for my exercise assessment students, very different numbers. So now it was 62% said they preferred it to be in person. And I think some of the difference here might have been, one, the type of assignment they had to complete from it. So these students had to actually interpret the data on their own, but also the type of tests that were done. So this was all exercise fitness tests, where for the exercise physiology classes, it was oftentimes a little more abstract, and oftentimes I could also make it simpler because it wasn't necessarily a fitness test. But still about 27%, so close to that 30% that preferred to be virtual. The difference, though, is far fewer people had no preference here. So even if you were to assume that these students had similar experiences and you kind of split the difference, about 50% of the students preferred to be in person, which was similar to the discussion-based labs, where there was also about 50% thought it should be in person. All right, so on to the last kind of lab here. This is the skill-based labs that I think fall clearly under the technique learning category. So the students, once again, were given handouts with an introduction section and method section that included text and video. Now they were also given laboratory kits. Okay, so they had, this is for the exercise assessment class only. We didn't do this for the exercise physiology class, but for the exercise assessment class, they were given skin fold calipers, circumference tape measures, and a blood pressure kit. And the full kit, so all of this equipment, was about $40 per person when I looked it up on Amazon just this week. When we purchased our kits, it was probably around $35, so that has gone up slightly in price. But there is a cost here, but it is reasonable compared to some of the other individual student kits that you can buy sort of pre-made that are typically much more expensive than this. Student responsibilities. They were to, so this is talking about when everything was fully virtual, when we were still in lockdown mode. The students conducted the tests on themselves or a subject, ideally a subject in their own home, someone they could sort of bring in and get to do it on Zoom. So we put them in breakout rooms, and I went through the breakout rooms and tried to answer questions, give feedback, and when someone was comfortable to do so, they performed the measurements with the camera on them so that I could watch them do it and I could kind of give them some pointers as they were going. The assessments for these skill-based labs in the exercise assessment class were through practical exams that were graded virtually, also through Zoom at a later date. So they did the labs to learn the techniques, and later on we did the practical exams. So let's talk about those practical exams some more though. They were one-on-one Zoom sessions, so each student was met with individually without any other student present on the Zoom meeting. And they were asked to arrange for a participant in their own life that could be used as a subject for the practical exam. Most students did find a participant. There were students, though, that were unable to find participants. So this was a little bit of a problem. So whenever they couldn't find participants, I had them test on themselves to the best of what they could. So I did some modifications when this was the case. So for the skin folds, so they did skin folds, they did waist and hip circumference measurements, they did heart rate, resting heart rate, and resting blood pressure. So for the skin folds, they did anterior sites only because they can't reach their own back and do the measurements. And for the blood pressure, they showed me how they would apply the equipment to their own arm, but it's kind of hard to wrap a blood pressure cuff on yourself. And so I had them do the blood pressure measurements on their leg instead. From that, I then focused my evaluation on them through visual inspection. So I watched them do the techniques and I looked for errors in the techniques, and that's what I was looking for during the grading. If I couldn't see something, I simply asked them orally, or if possible, I had them move the camera or move themselves so I could see it better. But if that wasn't possible, or I felt like it was going to be too challenging in that specific case, then yes, I just asked them orally what they should have done or what they could have done. And so in looking at the research literature here, technique-based learning from virtual and blended labs, this is from that Zhang review article again, 100% success rate across it's only 3 studies, but across the 3 studies, all of them showed that skill-based labs, or in their case, technique-based learning, was successful virtually. And so I also found that it actually worked a lot better than I thought it would. So in my instructor perceptions is most of the errors that students made, you can see, right? So if you can see it, then you can grade it through a Zoom or other virtual setting. And so again, most of the errors they make are something that you can see. The cons, accuracy was not assessed. I couldn't assess whether they were doing blood pressure and heart rate and skin folds accurately because I couldn't also test their participant because I wasn't there with them. So accuracy was not assessed. I instead focused more on methods and whether they follow sort of best practices. The students, another con was students did, as I already mentioned, find some difficulty finding participants. Most were able to, but maybe about 20% or so were not able to find participants. Student perceptions. So this is only from the exercise assessment students because this is the only class that I did this type of lab with. 54% preferred this type of lab versus the other types of labs that I've talked about today. Looking at whether they thought this should be virtual or in person for this specific type of lab, these skill-based labs, 77% said it should be in person. So an overwhelming majority said that these should be in person. So only 15% said virtual and only 8% had no preference. Now looking at the attendance data, so the actual attendance data for the sessions where we did the sort of training, not the practical exams, but the training. This is for my current semester, where again they were allowed to either attend virtually through Zoom or come in person and have an in-person experience. So when we did these skill-based labs, 56% of the students showed up. So far fewer than the 77% who preferred it to be in person. But when we look at the lab sessions where the classes where there are no labs or an asynchronous lab, the attendance rate was 22% in person, the rest virtual. So clearly, when there's a skill-based lab, it does boost attendance. This is different from what we found with the other types of labs I've shown you, where there's really no effect. But it doesn't completely overwhelm other attributes of the virtual versus in-person environment. So it didn't quite get to the 77% that preferred it. So again, I asked them, when attending virtually, why did you attend virtually? Same answers as before. Mostly convenience. So 58% said convenience. Only 15% said they were trying to avoid COVID-19. And only 4% said they preferred the virtual environment. Looking at why they attended in person when they did, 58% said they preferred the in-person environment. So again, that preference, and 12% for some social reason. So very similar answers to what we found when we looked at the other types of labs in terms of why they attended virtually versus in person. All right, so that rounds up all the types of labs that I've conducted virtually. So let's do some conclusions to all this. So affordable substitutes for in-person labs do exist and can be created if they don't exist. And for most labs and most learning outcomes, it can be done virtually in a successful way. So it is possible, as most of us have found, that it is possible when you need to. Student preferences, though, do lean towards preferring an in-person environment for the labs. They do desire convenience too, so these are kind of competing wants, right? So they want to be in person, but they don't want to have to drive to campus and park their car and do all that. So there is some competing interests here. The convenience of virtual versus the preference for in-person tends to balance each other out for most of the lab types, except for the skill-based labs, where it still seems as though the preference for in-person is a little bit more dominant than the desire for convenience. All right, so moving beyond COVID-19, so hopefully we are slowly moving past it. A mixture of in-person and virtual labs seems like it's probably an appropriate approach in the future, even when COVID-19 isn't a major concern anymore. But we do need more research in order to sort of back up this and also determine which types of labs are best in person versus virtual. But hopefully the information I showed today gives a little bit of an idea of which ones might be best to do virtually versus in person once you're no longer worried about COVID and your students are no longer worried about COVID. All right, so some quick acknowledgments here. I just want to thank Mark ACSM, so the Mid-Atlantic Regional Chapter of American College of Sports Medicine, for letting us present in this session. I want to thank the session organizer, which is Dr. Mukherjee, who asked me to be a part of the session. My research collaborators who helped develop that variable height step test, so Dr. Phillips and Fiona Horvat, and of course my students who sort of dealt with a lot of my fumbles over the last year and a half or so as we've dealt with this pandemic, and we're very gracious in dealing with those fumbles. And of course, Montclair State University and the Department of Exercise Science and Physical Education for their support throughout this time too. All right, so I hope this was helpful, and thank you for listening.